Hello, ladies and gentlemen. Today we are going to be talking about a certain type of notation that's used all the time when we calculate and run some actual math stats on our data, and that is called sigma, or also known as summation notation. So before we go into Unit 3 and calculating data on our data sets and like running some actual numbers on what's going on, we need to know how to work with this notation because it's going to be used in a lot of our formulas. So in Unit 1, we learned a little bit about what statistics is. We got our little toes wet. And then in Unit 2, we stepped more into the pool of statistics and got our feet wet and started talking about how we organize data based on just like if we were to be counting the frequency tallies of our data. And now we're going to be starting to organize more and calculate more statistics like mean, median, and mode, and more stuff on our stats when we have quantitative data. So before we can understand all the different formulas, we first need to figure out what this notation is. Okay, so sigma notation. This is on the front of your foldable. If you don't have a foldable, there should be some in the room somewhere so you can find them. But on the front of your foldable, this is what sigma notation looks like. How we read it is we look at the bottom of this and we say the sum from I to n. So the sum, because we also call this the summation sigma, okay? The sum from I to n of a sub I is going to produce this pattern, where I is the index of the summation, a sub I is the ith term, I is the lower bound, and n is the upper bound of our summation. So make sure you get those definitions for I, a sub I, and n written in your notebook. Okay, so what's happening is when we talk about the sum of something, we have a pattern, and not only are we producing a pattern, but we're going to add each one of those terms of the pattern together. So how we would write this is each of the terms is in the form of some number getting squared, where k is an integer from 1 to 5. So how we would write our sigma notation is we started with 1, we ended with 5. Each one of those terms, so we started with 1, we ended with 5, that's my lower and upper bound. Each one of those terms is getting squared. So really in the last one, we said our index is I. That letter can be anything. So if you look on this next one, we can do K, we could do X, we could do N, we could do anything. We'll probably stick with K rather than I, actually. So our index will usually be written in variables of K. So how we would produce this summation is we start at 1, and wherever we see that K, we're plugging in all the integers from 1 to 5, starting at 1 going to 5. So it'd be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. And then the goal of today is to actually calculate what this summation is. We should get a final number for our final answer. So that's how the directions will be written when we need to find the answer, is determine the sum. When you say sum and you spell it S-U-M, that's talking about if you were to add things together, what would your final answer be? So here's our summation notation, or our sigma. We're starting with our first term being 1, going all the way to 4. So counting from 1, 2, 3, 4, and we're stopping at 4. So we're going to plug each one of these numbers in for our 4 terms into that pattern. So our first term would be 1 plus 2. Our second term would now be plugging in 2, so 2 plus 2. Our third term is going to be 3 plus 2. 1, 2, 3. We have one more term because we're going all the way to 4, so we're plugging in 4. So when you determine the sum, all you're doing is looking at your lower and upper bound and plugging in each of those integers or whole numbers into that pattern, and then we're going to add those terms together. So 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2 is 6. So now that's our last step, is to take 3 plus 4 plus 5 plus 6 is 7, 18. So that's our final answer, is 18. That's the goal. The sum should be a final number. Okay, let's look at this one. So our index K is starting at 3 and ending at 5. So we're going to have 3 terms with 3, 4, and 5 being plugged in for K. So our first term is going to be 3 times 3 plus 3 times 4 plus 3 times 5. So my first term overall is 9, my second term is 12, and my third term is 15. So now we're taking 9 plus 12 plus 15 to get a total of 36. So that is my sum. Okay, now it's getting a little more complicated. So we have to plug in k in multiple parts. There's multiple k's in our pattern. For the first two examples, we only had one letter k in our pattern, but now we see a k as an exponent and a k as a normal variable attached to a coefficient. I'm going to erase that so we can see the pattern again. Okay, bear with me. I have a new pen, so I'm getting used to all the intricacies of writing with my new pen. Okay, so like I said, I have a new pen. Sorry about that. Okay, so now we have starting at k is 0. So we're plugging in 0 and then counting all the way up to 4. So 1, 2, 3, 4. So we're plugging in 5 terms because we have 1, 2, 3, 4, and we're plugging in 0. So we have to plug in 0 first. So it's going to be -1 to the 0 all times 2 times 0 is 0 plus 1. So I'm going to do some mental math so we don't have so much to write down. Okay. We're plugging in 1. So it's going to be, oops, sorry. Oh gosh, let me go back. Okay, so it's going to be -1. Now we're plugging in 1 raised to the first all times. 2 times 1 is 2 plus 1. That's my second term. Plus, now we're plugging in 2. So it's going to be -1 squared all times 2 times 2 is 4 plus 1. I'm going to run out of room, so I'm going to have to write 2 lines, okay? Plus, now we're plugging in 3, so that's going to be -1 to the third, all times 2 times 3 is 6, plus 1. We're plugging in 4. Our last one is going to be -1 raised to the fourth. 2 times 4 is 8, plus 1. Okay, so now we need to simplify each one of those terms, each one of those 5 terms. So let's look at this first one. Let me grab a different color. So we're looking at this first one. -1 to the 0. Anything to the 0 power is going to be 1. So 1 times what's in parentheses, 0 plus 1 is 1. So it's 1 times 1, which is 1. Now moving on to the second term. -1 raised to the first power is going to result in a negative answer. 2 plus 1 is 3. Going to the next term, -1 squared is just going to be a positive 1. 4 plus 1 is 5. Okay, plus -1 raised to the third is going to be a negative times negative times negative, which will result in a negative. 6 plus 1 is 7. -1 to the fourth is going to be a positive again. 8 plus 1 is 9. So if I simplify it to how we normally write, we don't say plus -3. We typically just say minus. So we have 1 minus 3 plus 5 minus 7 plus 9. So really all the -1 to the k does is alternates the signs between your sum. Because we went from plus minus plus minus plus. So all this -1 to the k is doing in the pattern is alternating our signs. So that's the only thing that's really changing our pattern. Everything else is just the 2k plus 1. So it looks kind of daunting when we have -1 raised to the k, but all that is saying is that our signs are going to alternate. Starting with 0 means we're going to start with a positive, and then it'll alternate from there. So we started +1 minus positive minus positive. Okay, so now we actually have to figure out what 1 minus 3 plus 5 minus 7 plus 9 is, and that should be 5. Okay, we're going to have some, so we're understanding what summation notation is, and then we're going to go forward in formulas with more stuff happening to this summation and notation. So some properties that are going to be super helpful moving forward when we look at our formulas are these 3 properties. So if we have some constant, that's what C stands for, in front of our pattern. So let's give you a more concrete example. If we have the pattern, let's say the sum from, I don't know, k equals 2 to 5 of 3k. We have a number in front of our pattern. That is going to be the same as if we were to pull out that coefficient in the front of the sum. Oops, sorry, I just wrote that wrong. So if we pull that 3 out in front of the sum, so from k equals 2 to 5 of k, that is going to result in the same thing. So you can do the pattern, like take 2 plus 3 plus 4 plus 5, and then at the very end times it by 3. That's going to get us the same exact answer as if we did 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. Okay, when I get back, when we're back in class together, we'll work more on these properties. Okay, that's the first property. Second property, if you have in a pattern some term plus or minus another term, it is the same as breaking it up into 2 separate summations. So if it's easier for you to break it up into 2 separate sums so you don't have such a long pattern, you will result in the same answer, okay? And then finally, the last one, if we have a sum of a number, so if it looks like this, like k equals 1 to 3 of 4, and we don't have an actual k in our pattern, all that's happening is we're repeating the number 4. So we're saying 4 plus 4 plus 4. So for the first 3 terms in my pattern, it's going to be the constant 4. So the shortcut is to take that number times however many terms we have. So that would be 3 times 4, which is 12 in this case. Okay, so in this note specifically, we won't work with these properties, but I thought it was appropriate to talk about them in this foldable. And then here are some more useful theorems. To be quite honest, I wanted them written down somewhere in your notebook, but we'll reference them as we need them when we go through the rest of the unit. So this is where you can look back on these useful theorems with summations. Okay, so the last 3 examples for today. The first 3 examples that we did was we determined the sum. So we were given the sigma notation and we had to find what the number was. Now we're given the pattern and we need to come up with what the sum should look like. So we should have big E. Oops, what's going on? We should have big E, and I keep giving away the pattern. Okay, so we should have big E with k starting at some number, going all the way to some number, and then we should have a pattern. So we have 1, 2, 3, 4, 5. So we have to figure out how are we moving from 1 to 4, 4 to 9, 9 to 16, 16 to 25. So it doesn't seem linear because we're adding 3, then we're adding 5, then we're adding 7, then we're adding 8. So that doesn't seem like that works. But we should recognize that each one of these numbers are a perfect square. So like this would be 1 squared, this would be 2 squared, this would be 3 squared, 4 squared, and 5 squared, and so on. So our pattern is that the number that we're plugging in is getting squared. So we're starting at 1 and we're ending at 5 squared. So we're going from 1 to 5 and our pattern is k squared. Sometimes establishing the pattern is the hardest part, is trying to figure out what the pattern is going from one term to the next. I think it's a lot easier to determine the sum than to do what we're doing on these last 3 examples. Okay, now we're going from 1, 2, 3, 4, 5, 6, 7, 8, 9. And what do you notice in between each one of those constants is that our signs are alternating. So remember back to example number 3 from the beginning of our foldable, we said alternating signs happen when we have a -1 raised to a k. So if we have -1 raised to the k and we want to start with a positive sign, we know that k's index has to start at 0, because if we started with k is equal to 1, we would have started at a negative and then we would have been alternating from there. That wasn't happening, so we know that we need to start at 0 so we can start the pattern positive. Okay, we're going, so if we start at 0, we have 0, 1, 2, 3, 4, 5, 6, 7, 8. We're going all the way up to 8. So since we plugged in 0 first, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we know that we're ending at 8. Now we have to figure out the pattern. The pattern looks like it is simply just increasing by 1. But we don't need to say k plus 1 because we're starting, oh no, just kidding, we're starting at 0, so we do need to say k plus 1. I'm going to rewrite this down a little lower so we're not super confused. Okay. We said k started at 0, went all the way to 8. We definitely know we have alternating signs. Then we need to figure out how we went from 1 to 2 to 3 to, and we're increasing by 1. But since we're starting at 0, we know that it has to be k plus 1. Because in order to plug in 0 first, we have to get back 1. So if we plugged in 0 into our pattern, negative 1 to the 0 times 0 plus 1, we would get back 1. So this is our final pattern. Just to show you, there can be multiple different ways to write the summation given the pattern. So if you came up with something else where you did like, I don't know, negative 1 to the k plus 1 so that you could get back to a positive, that would change your pattern, but that doesn't, the rule to your pattern. So there's multiple rules that can be created from one singular pattern. So if you found it in a different way, that's okay. But when we have sum in front of us, there's only one way to solve. There's only one way to plug in the numbers. Okay, let's look at, oh, that's where it is. Okay, sorry, I was one notation behind. Here we go. So I solved it starting with k is equal to 0. But you could also have solved it with starting k is equal to 1 going all the way to 9. So look at how the pattern would be different. We'd have to change the exponent to be k plus 1. And then our real pattern that's happening is we're just plugging in each number from 1 to 9. And that's it. There's nothing else happening to it other than the alternating signs. So there's definitely more than one way to determine the summation when given the pattern. Okay. Okay, the last one. Here we go. So this is just one designating the notation. So k starting somewhere, going to somewhere. So if we look, just getting used to the notation, between each of these terms, the only thing that's changing is the subscript. So we're starting at 1, we're ending at n, whatever n number we want it to be. And the only thing that's changing is the subscript. So it would be a sub k, b sub k. That would be our final answer. So that's just getting used to the notation. Okay, that is all that I have for you in this foldable. Make sure you get all of the stuff written down that you need to write down. And if you have more questions as we move forward with summation and sigma notation, please, please, please be sure to ask me when we're in class because I know that this notation can get super confusing. So if you have any questions about the notes or on any of the future homeworks, please let me know. Other than that, I want to thank you for taking good notes and have a good day.